In this video, we're going to talk about how we communicate data from function to function. Supposedly, you have two functions, function A and function B. We're going to talk about how we pass data from A to B, from B to A, and also from each other, right? And notice that this is how data transfer, right? Gets transferred from A to B, B to A, and vice versa. In general, a function takes a set of input and outputs to somewhere else. And sometimes the output of one function becomes the input to another, right? So this means that how we strategize and design the communication flow from where data should go from one end to the other is important. So we're going to look at the basic concept in communicating data among functions, and also the specific implementations details, right, in C. In general, the C language uses call by value. So this is the same as pass by reference, pass by value, right? So when you have a function that takes a set of inputs here, the very first thing that happens is, let's say this function f makes a copy of this x inside of the function. So this x becomes a local value inside of the function. The function can do whatever it is with it. And then there's an output, right? So it depends on what this x is being used for. But the bottom line is when we do a pass by value, we're passing the value of the parameters, and this value itself, right, gets copied locally inside this function. Well, look at the specific examples that illustrate this. In general, this also applies to pass by pointers, pass by references. Nonetheless, whatever you pass in, right, as a parameter is being copied. So if you're passing a function pointer into this another function, or we pass a pointer or we pass a reference, right, into a function, a copy of that reference, that function pointer, that pointer, they'll get copied inside this function. It becomes a local variable. So there's actually a local copy of whatever you passed in, right, by value inside this function. So function can do whatever it needs to, right, to this parameter inside of the function that will have no effect to the value of x outside of this function. Okay, so let's take a look at the specific example that illustrates this. This is an example of where we have two functions where one function calls another. So in this case, the upstream one is main. Main calls down fun, right? So this is passing in basically two integers, and you can see these are values that are received by the downstream function. So what happens is when you pass a, right, into this function, or 15 into this function, there is a local copy of that x and y. So x is whatever this a value is. In this case, we don't know, but we know y is 15, right, from this prior calling functions here. So there's a local copy of this x and y being created here. So whatever you do to it, let's say x plus plus, y minus minus, that would have no effect to the value of a and 15 outside of this function in this main function in general, right? This is a specific example illustrating what I was talking about earlier, pass by value, right? So when you pass a, right, and 15 into this downstream functions here, and this is passed by value, okay? Meaning only the value here. We're not talking about pointers or references here, simply just a value itself. Right now, we're making change. This is the side effect we're talking about earlier, right? So you're making some state changes affecting the change, the value of your x. In this case, x equals x plus y. As you can see here, x then becomes 20, right? Because 20 equals 5 plus 15 that gets passed in. But however, this x and y sitting inside of this functions here are only local to this particular functions, right? So if you go point out the value of a here, this prints 5. Why? Because whatever happens inside this down function happens inside this down function here, because this down function is simply just making a copy of x and y, right, in value, and making some changes, and they're producing something we call local side effects here, and nothing goes outside of this down fun. So when you come out of this down fun into the very next line of code, printing out the value of a, it still prints 5, not 20, right? So this illustrates how we pass value, right, or values, right, from a downstream perspective, meaning one way, right, from main, right, into this right, by value. Okay. Now, this is the opposite of downstream communication. This is upward communication, right? Actually, what this example illustrates is this is what we call pass by pointer. As you can see here, when you say an integer here with a start, this is what we call integer pointer, right? So in this case, you have two integer pointers. You're passing these in. So long story short, we know you might have had some studies on pointers, but if not, that's okay. What this is saying is you have two right integers here, and you're passing in the address. Okay, this ampersand stands for address of. Now this is very different, right? From that of passing in just A and B by value, you're passing in the address, right, of A and address of B. So technically, right, this is your memory footprints here. When you ask the program to create, right, on the stack, a value of A and B, they occupy various different addresses. Let's say this address here is 0 times FA2. And this address right here, by the way, addresses are all represented in hexadecimals in programming. So you have XA 0 times Z, right? K 5, right? So I just made those two addresses up, but long story short, you're passing in these address, which in of itself an integer. Even though this is a hexadecimal, right? Hexadecimal is really just a decimal, right? Which is a integer. So you're passing an integral value, right, into this downstream, quote unquote, downstream function called up functions. Now, the interesting thing is when you dereference these two variables, and by the way, when you have extras in front of the variables, this is what we call dereference. Okay, I know this could be somewhat advanced. So if you haven't had pointer studies before, don't worry about it. Dereference means that you're simply just asking for the value that is stored inside this pointer or this pointer pointing to. And you're changing that value of X, Y, in this case, what you passed in as a parameter to a value of 23 and 8 respectively. Now, by virtue of doing this is you're actually changing the value inside of A and B. This one is 23 and this one is 8 after some manipulations here, namely dereferencing operations. Even though you're not passing the value themselves into the function, you're passing the address, right, of the variable that stores, right, these values. So by passing the address, by dereferencing it to get the value inside of it, you're changing the value of the values that you're passing in. So this is just a more in-depth view of pass by pointer, right? Pass by pointer. So we illustrated from the previous slide. In fact, when you have two local variables here, you simply just pass in the address of these variables and try to do something with it using a dereference, right? Operations, and change the values stored inside this AXAY. You're actually changing the value of A and B because both of these A and B, right, share the same memory address. Why? Well, because you're passing in the memory as A and B. So inside this upper up functions here, even though this is a copy, right? A copy of someone else's memory address. That memory address is the memory address of A, is the memory address of B. So when you're manipulating these values by their pointers and try to store or change the value to where this pointers point to, you are actually changing the value of A and B in general. Okay, so this is an example of outward communication, meaning by passing something by references into another place. And when you change those values in another place, you're changing those values in the original place as well. So it's almost like, if you can think about this as remote controlling the value, right, from afar. And remote as in, you're controlling these value inside another function called main. This is more of a summary how we pass, arguments by pointers. And in general, this is what we call the recipes. If you haven't studied pointers, you don't have to worry too much about this. This will be self-explanatory, but simply summarizing what we just did. Let's say if you have an integer that you wish to pass into a function by pointer, you simply attach an ampersand in front of that I. This gives you the address, okay, of I. The address of I is actually a definition of what a pointer is. Assuming I is in this case, integer, then that pointer itself will be integer pointer. So that's number one here. So you have two functions, right? Passing, this a function A to B, passing I, right, as the data from A to B, requires the very first step. The second step is inside B, this is where you define your parameters. That parameter has to be integer pointer, meaning integer star, right? You can call it integer J, right? For some reason, it doesn't really matter. So inside of this, we have to use the ampersand. And then if you want to effectuate changes to this I, because this J is really an I, although J stores memory address of I, in order to change the value of I, you have to dereference J, right? You can only dereference on a pointer variable. So you put ampersand J in this case, and this simplifies the dereference. You're trying to get to the value of J, which is I, right? Because J and I are, so if you think of this is I and this is J, so J stores the memory address of I. So memory address is 0 times FA, and this is where 0 times FA is, right, in J. So when you dereference J, you're actually pointing to the value section of your I right here, right? So this is the reason why you put ampersand in front of J to get to the value of I. And so if when you change this 23 actually goes into here, right? Anyway, this is a little more advanced, but this is how we, send data from the call function to the calling function. So in this case, A is what we call the calling function, and B is what we call the called function, or the function that's being called. This example illustrates the, the OPBOR or bidirectional communication involving use of pointers, right? In this case, we're passing in, the two addresses of A and B, right? And then you do some changes in this directional functions here by dereferencing them. So the effect of, the value of AX and Y, which actually points to A and B, respectively, got changed. So this is a more in-depth illustration of the same thing that we just talked about here. If we scroll down to this, again, this is another examples you can read into this. When we get into the pointers topics, we're going to talk more about the addresses of the pointer definitions and how we dereferences these things. So these are more advanced topics that are associated with the topics when we get into dynamic memory allocations involving pointers. This is another example of the sort of the mixed uses of passing by pointers and passing by values, right? So as you can see in the divide, which is the functions here, you have both types, 4 parameters, and 2 of those, right? The first 2 are passed by value. The second half are passed by pointers, right? So in this thing, you can actually have, values that gets stored right inside the divide, like your A and B as local variables. However, for quotient and remainders, these things actually got flowed back because they're passed by pointers. So you can actually effectuate a value of quotients and remainder inside of this divide function remotely. So in other words, looking at this, your main function is almost like a remote entity, right? So you're able to operate your quotient and remainder remotely, right, to effectuate some changes, to get some values in, and then take back with you, what the remaining value is. This is an example that kind of illustrates the mixed use of pass by value and pass by pointers. So this is an example of a program that reads 2 integers and prints the quotient and remainder, making use of pass by value and pass by references to enable this mixed use of upward, downwards, and bidirectional, data communications involving functions.